Okay, so we will talk about 4 special right triangles today. Okay, so before we talk about these 4 special right triangles, let's talk about notations, labelings in the right triangle again. Okay, right triangle again. So in most case, we use letter C for the right angle. Okay, for the right angle, and then the opposite side of the C, of the angle C, we use lowercase c, and this is the hypotenuse of the right triangle. Okay, our triangle. So for letter A and B, the order doesn't matter. Okay, the order doesn't matter. So if you choose this angle to be angle A, then the opposite side of angle A will use lowercase a. So that's the A side of right triangle. Okay, A side of the right triangle. Okay, the length of this vertical side is lowercase a. Okay, lowercase a. And then the top angle will be B. So the opposite side of angle B is the B side. So is the length B, lowercase b. Okay, lowercase b. So these are our 3 angles ABC and 3 sides ABC. We use opposite side. Okay, we use opposite side, opposite angles to label it. Okay, to label it. So that's not the definition of trig functions. Okay, definition of trig functions. So when you look at the trig functions, right? When you look at the trig functions, so let me draw the right triangle again. So now we know here is C, here is A, here is B. So let's not just use blue color, emphasize the angle A. Okay, this angle. So when we talk about the trig functions, first we have to talk about the angle of the trig function. Okay, so angle is A, then we need the opposite side of A. Is A side, right? So that's what we did before. And then we cut the other side. B side is the adjacent side of A, of angle A. Okay? So adjacent side means it's a part of angle A. Okay? So B side is the adjacent side. Okay? And hypotenuse never change. Hypotenuse is the opposite of C. Angle C, the right angle, so hypotenuse is C. Okay? Hypotenuse C. So when we define the trig values, we need the opposite adjacent sides of angle A. Okay, angle A. So now what is sine A? What is sine B? Sine A and cosine A, sorry. So sine A will be opposite over hypotenuse. Cosine A is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, adjacent. You flip them, you got the other 3 trig values. Okay, the other 3 trig values. So now if you look at angle B, right? So if you look at angle B, so what's the opposite side of angle B? Is the B side, right? And then adjacent side of angle B will be A, right? So this is A side, the vertical side is a part of angle B, right? Angle B, so that's angle B. Okay, yeah, so hypotenuse is C. Okay, hypotenuse is C. Then we get sine B. So for the sine A is A over C, but sine B, so this will be opposite of B over hypotenuse. So this is B over C. Okay, B over C. So cosine B will be adjacent over hypotenuse. So this is A over C. And then tangent B will be opposite over adjacent. So it's B over A. Okay, B over A. And for angle A, adjacent over hypotenuse. So cosine, this will be B over C, and this is A over B. Opposite over adjacent. Okay, opposite. So when we talk about right triangles, we use opposite side, opposite angles. Okay, when we talk about trig values, we use opposite side and adjacent side. Okay, adjacent side. Okay, so now let's talk about special length right triangles. So we have two special length right triangles. Okay, two right triangles. So the first one is 3, 4, 5. Okay, it's 3, 4, and 5. Okay, 5. 5 is the hypotenuse, that's for sure. This is the C side, the hypotenuse. Okay, hypotenuse. So let's use the same labeling. If this is A, this is B, then sine of A, which is opposite side of A divided by hypotenuse, this will be 3 over 5, right? Opposite side of A is 3. Okay, opposite side of A is 3. Okay, and the cosine A, it will be adjacent side over hypotenuse of the angle A. So this is 4 over 5. Okay, 4 over 5. And then tangent A, so this is opposite over adjacent, so this is 3 over 4. Okay, 3 over 4. So the other three, right? The other three. So cosecant A is 1 over sine A. So you flip sine A. Okay, flip sine A. So this is 5 over 3. And secant A is 1 over cosine A. So you flip cosine A, so 5 over 4. Okay, 5 over 4. And cotangent A is the flip tangent A. So this is 4 over 3. Okay, 4 over 3. So that is for angle A. Okay, that is for angle A. So now let's look at the same example for angle B, right? For angle B. 3, 4, 5, and then angle B. Okay, angle B. So we're looking at this angle, right? This angle. Now the opposite side is 4. Okay, opposite side is 4. So sine B is opposite over adjacent, over hypotenuse. So it's 4 over 5. Cosine B is adjacent of side B over hypotenuse, so it's 3 over 5. Okay, 3 over 5. And tangent B is opposite of B over adjacent, so this is 4 over 3. Okay, 4 over 3. So the values of angle A and angle B trig values are completely different. Okay, completely different. So let's finish the other three. Cosecant B is 1 over sine B, so 5 over 4. Secant B is 1 over cosine B, so it's 5 over 3. Flip cosine. Cotangent B is 1 over tangent B, so flip tangent. So we got 3 over 4. Okay, 3 over 4. So 3, 4, 5 is our first example of special length right triangles. Okay, special length right triangles. Okay, and you can easily check 3 squared plus 4 squared is 5 squared, the Pythagorean theorem. Okay, the Pythagorean theorem. So the biggest one, longest side 5 is the hypotenuse. So that's our first one. Okay, so now let's look at the second one. Okay, let's look at the second one. So the second one, I'm going to write down the trig values for angle A and angle B together on the same page, but only for the first three. Okay, only for the first three trig functions, sine, cosine, tangent. Okay, so the second example is 5, 12, 13. Okay, 5, 12, 13, and 13 is the hypotenuse. Okay, is the hypotenuse. So angle A, let's use red color, and angle B, let's use green color. Okay, green color. Okay, I draw the opposite side inside the right triangle. Okay, right triangle. So So now let's talk about A first. So sine A, opposite over adjacent, so opposite over hypotenuse, so it's 5 over 13. Okay, cosine A is adjacent over, this is adjacent side of A, right? Adjacent over hypotenuse, so it's 12 over 13. And tangent A is opposite over adjacent, so it's 5 over 12. Okay, 12. So for angle B, sine B is opposite of B over hypotenuse, so it's 12 over 13. Cosine B is adjacent, so this is adjacent of B, adjacent side of B over hypotenuse. And tangent B is, so opposite over adjacent, so 12 over 5. Okay, 12 over 5. So you flip them, you got the other three. Okay, you got the other three. So later we will put these two triangles in the coordinate plane, and then we can solve more questions. Okay, more questions. So our first triangle is 3, 4, 5. The second one is 5, 12, 13. Two special integer length right triangles. Okay, so now let's look at two special angles right triangles. Okay, so the first one is easy. The first one is we start from a square. Okay, so this is a square. Okay, a square unit square of length 1, and then when you cut along the diagonal, you got the right triangle. Okay, you got a right triangle. Okay, so let's first calculate how long is this diagonal. Okay, how long is this diagonal? So this is the hypotenuse C. 1 squared plus 1 squared is C squared. Okay, so I'm looking at this right triangle. This is right triangle. You can use the other one. They are the same. Okay, they are the same. So 2 is C squared. So radical 2 is C. Okay, radical 2 is C. So this diagonal is square root of 2. Okay, square root of 2. So our first special angle right triangle, the length is 1, 1 radical 2. Okay, 1, 1 radical 2. So now what's the corresponding angles? You have to remember it. Okay, remember it. So this angle is 45 because it's half of the right angle. Right angle is 90, and this is 45. Okay? So one way, if you use degree measure, this is 45, 45, and 90 degree right triangle. Okay, right triangle. So if you use radian measure, next week we will talk about the radian measure. This is pi over 4, and pi over 2. Okay? Yeah. So you can also label them using the radian measure. So I like the degree measure. Okay, I like the degree measure. Most case I will just use degree measure. 45, 45, special right triangle. Okay, special right triangle. So now there is an equivalent way to write down this 45, 45, 90 right triangle. Okay, so let me put the old example here. This is 1, 1, square root of 2. So this is 45. This is 45. Okay, so the other way, sometimes they use radical 2, and then diagonal 2. Okay, diagonal 2. So sometimes people also use this one. So square root of 2, and 2. So you have to remember all these 6 informations. Okay, 3 angles and 3 lengths. Okay, 3 angles and 3 lengths. Okay, yeah. So for the trig value, which one is easier? This one. Okay, you just enlarge everybody multiply by radical 2. You change the blue one to the red one. Okay, the red one. It's just different size, same shape. Okay, same shape. So why the red one is better? You can see when you write down sine of 45. Okay, so now because both angles, this is 45, this is 45, it doesn't matter which one you pick. So you just pick the bottom one. So 45 opposite is radical 2, and then hypotenuse is 2. Okay, so most case hypotenuse is the denominator. So This is denominator 2, this is denominator radical 2, so that is better. Okay, that is better. You don't need to rationalize denominator. Okay, yeah. And cosine 45 is the same, radical 2 over 2, because the bottom side is also radical 2. Okay, and tangent 45 is opposite over adjacent, they're the same number, so it's 1. Okay, so it's 1. You flip them, you got the other 3. Okay, you flip them, you got the other 3. So for this 45, 45, 90 degree special angle, right triangle. So you should remember either 1, 1 radical 2 or radical 2, radical 2, 2 special lenses. Okay, special lens, special angles. Okay, yeah. And then you can find the trig values by using opposite and adjacent. Okay, yeah. So that's half of the square. We got 45, 45, 90. Okay, yeah. So the next one is half of the equilateral triangle. Okay, equilateral triangle. So what means equilateral triangle? Basically, you have a triangle, and then you have the same length. So let's assume here the length is 2. Okay, so everybody has the same length, and everybody has the same angle, 60 degree angle, 60, 60, and 60. Okay, so next week I will tell you how to change degree to radian, radian to degree. So 60 is pi over 3. Okay, it's pi over 3. Okay, so all the 3 sides of this triangle has length 2, and all the angles has 60. Okay, 60. But where's the right triangle? Okay, we're talking about the right triangle. So just like the square case, we cut in the middle. Okay, we cut this to 2 smaller right triangles. Okay, so here is the midpoint of the bottom side. So this is 1. Okay, this is 1. So let's just draw this part. Okay, just draw this part. So we got a right triangle. Bottom side is 1. This side is 2. So how to find the other side? Use Pythagorean theorem. Okay, use Pythagorean theorem. So let's assume this is b. So 1 squared plus b squared is 2 squared. So 1 plus b squared is 4. Minus 1 minus 1. b squared is 3. So b is radical 3. Okay, b is radical 3. So the length of this special right triangle is 1, 2, radical 3. So now what about the angles? So the angle, this is 60. Okay, and this right angle is 90. So what's about this top angle? Top angle is half of the 60 because we divided to 2 equivalent parts. Okay, so 60 divided by 2, this is 30 degree. Okay, 30 degree. So this right triangle is 30, 60 right triangle. The other one is 45, 45. This is 30, 60. Okay, 30, 60. Okay, so now let's draw this again in a different way, right? In a different way. So this is 30, this is 60. So what's the opposite side of 30? 1. Opposite side of 60, radicals 3, and then hypotenuse 2. That's how I remember this special right triangle. Okay, so opposite of 30 is 1. Opposite of 60 is radical 3, and then hypotenuse is 2. Okay, hypotenuse is 2. So now let's write down sine and cosine of 30 and 60. Okay, it's 30 and sine of 60. So sine of 30 is opposite over hypotenuse, 1 over 2. Sine of 60, opposite over hypotenuse, so radical 3 over 2. Okay, so cosine of 30, so this is adjacent of 30 over hypotenuse, so radical 3 over 2. And cosine of 60 is adjacent, this is adjacent of 60 over hypotenuse, so this is 1 over 2. Okay, 1 over 2. And then tangent of 30, so this is 1 opposite over adjacent. And then tangent of 60 is opposite over adjacent. Okay, adjacent. So this is the trig values for 30 degree and 60 degree. Okay, 60 degree. So you have to remember the 3 lengths and remember their corresponding opposite side. Okay, opposite side. And another way is larger angle has larger opposite side. So if you remember 1, 2, radical 3. Okay, so smallest is 1, so opposite to 30. The middle one is radical 3, opposite to 60, and then the longest one is 2, so that's the hypotenuse. Okay, that's the hypotenuse. Okay, so finally we may meet some question like this, right? So let's say we have tangent 45 plus sine 30 degree. How to find this, how to solve this question? So first you draw two right triangles, 45, 45, radical 2, radical 2, 2. That's for 45 degree. And then we got this 30, 60. There's a 1, radical 3, and 2. Okay, and then we use definition. So what's tangent? Tangent 45 is opposite over adjacent. So this is radical 2 over radical 2 plus. What is sine 30? Opposite over hypotenuse, so 1 over 2. So this is 1 plus 1 over 2. So this is either 1.5 or 3 over 2 or 1 and 1/2. Okay, it doesn't matter what kind of form of the answer you give me, so that's the calculation. Okay, that's the calculation. Okay, so nobody can remember all the trig values for 30, 60, 45. You have to remember two pictures. These two pictures. And then use definition of trig functions to solve the question. Okay, to solve question. So we have 4 pictures today, right? Let's put the other 2 here. Special length 3, 4, 5. The other special length 5, 12, 13. Okay, 13. The longest one is always the hypotenuse. Okay, so that's our today's lecture.